I doubt we're going to be able to do this one. I'll pass. Let's do an easy one. Computers. Given an integer num, return the number of steps to reduce it to 0. Okay. One step, if the current number is even, you can divide it by 2, otherwise you have to subtract 2 from it. sure this is going to be more efficient than just asking even odd. Well, actually, no, what we could do is, arithmetic shift regardless of whether it's even or odd, but if it's odd we add 2, and if it's even we add 1. Interesting. Still not sure, still not obvious that that's going to be more efficient, but... Actually, it's also a pre-doped. My microphone's quite loud. Okay, so we're going to see number of steps. Alright. I'm thinking this arithmetic shift might be more efficient here because we don't have to perform the two operations in the odd case. We're taking advantage of the fact that 0 is even, incidentally, here. Number of steps, so we'll do divide sub 1 2 divide 1 2 Alright. Now what would the test be? Let's make that part of the thing here. Do 1000. Alright. And now it's gonna be time map number of steps to A. 515. Okay. Curses. Is there, instead of map, could we do, because I want to perform multiple tests, but I don't want to have to pause this every time and then scroll up. Oh, look, that's faster. Let me see. Time, and we do... yeah, well, there's nothing we can put here that would avoid, like if we did void instead. Let's see. We might be able to do... Can't do that apparently. We might be able to... Well, what if we just did for each anyway? Oh, look at that. Alright. A little on around 300. Alright, this is about 400. Which seems to hold. Alright, let's send it. Alright, so we want to put this up here. What? What is that dot dot dot? Okay. That's a problem. Hmm. Okay, but we always get down to, we always get down to this, right? Do we? What do I mean? So we always arrive at 1, and then it's 1 is odd, and we add 2. Alright, so the trick there is to start this counter at -1. Instead of doing sub 1 counter integer. Well, the first trick is to observe that we can do sub 1 counter integer because we always hit 1, and then we always add just 1 too many. And then the second trick is to observe that starting the value at -1 does the same thing as running that arithmetic every time, except more cheaply. We have to make this 25% less efficient to handle exactly 1 case. It's not really 25% less efficient. Let's just start with 0 then. Nah, that doesn't help. We'd as well start with -1, because even if we'd started with 0... no, never mind. Because we wouldn't have started at positive. Yeah, never mind. Alright, so if we plug in 0 here... Well, no, because, yeah, we have to ask... because we have either to do sub 1 if it's 1, or if it's this singular case, then... That's so deflating. I guess I don't know why I have such a strong emotional response to that, but... It's really deflating to get... to have this neat idea, and then... edge case, gotcha. Gotcha. You don't get the fun, interesting, efficient solution. You get garbage. You get to write garbage. Go on, write the garbage. Go on. Go on, write the garbage. Do the thing. So we have to ask the if check. Either way. So the only question then is whether we have to perform sub 1 or not. Mm-hmm. Oh. Ah. Yeah, if you have -1 here, you have to go with signed integer. That doesn't make any difference in Racket, but it does make a difference in other languages. I think it doesn't make a difference in Racket. Hmm. There are only 4 digits here. Or wait, 10 to the 4, what is that? No, that would be 10 to the 3. Eh. I was considering just making a hash table with all of the combinations. Actually, we could still do that, right? It'd be a bit larger and less wieldy, but because we have 5 digits, each one of which can have 2. It'd be 25 entries, right? 5. Oh, I have to remember my combinatorics. Choice of 2, choice of 2, 2 to the 5th, which would be 2, 4, 8, 16, 32. That's a little bit less wieldy. Yeah, and figuring out how to lay out the hash table to capture all the cases would be tedious. All right. Let's see. This was 1342. Do the thing. Could have tested this to see if it's slower. Yeah, whatever. Okay, let's take new lines. Okay. Now. Let's see. Trying to think of how you do this with minimal overhead. How do you do this with minimal overhead? So the idea that strikes me is to, well, you know, if we were using this millions of times a day, we would just have a hash table. Well, so let me test the string to number. Okay. We could write a program that generates all of the combinations. Let's see. No, I'm not sure how to do that. If I did. If I put a list together, so it'd be 10, we do in combinations list 99999666666. And then we remove duplicates. Actually, racket sequences. Okay. Well, actually, if I just do combinations and remove duplicates. So this should rather be permutations. So you can't ask for maybe the idea would be we intermix that work length. Oh, that's quite something. Yeah, okay, so now we need to define list to number function input list integer accumulator accumulator integer and exponent integer. Alright, so cons null input integer, then output accumulator integer. Okay. Actually, this could be an if. This maybe is where we're supposed to be learning for. Accumulator integer else list to number function CDR list integer plus accumulator integer star. Yeah, we're recalculating the exponent every time we do this. Multiplier integer star accumulator integer multiplier integer star multiplier integer 10. Okay. List to number list. So this goes in reverse, but actually that doesn't matter for this case. 0. What? Rather. Doesn't matter in this case because we have the permutations of this. So now otherwise we would need these to be the reversed numbers. Okay. Now, actually, what we could do is let's see. String, hold on. Let me think here. Right, so there's a specific command that we've learned recently for making strings out of number. String. Okay. Yeah, let's bind tilde to something. I'm not sure if this will work, but we can try it. No, that's not gonna work. Yeah, okay, let's see. That works. I have to remember it, but whatever. Not remap a key, rather remap a shortcut. Okay, and what we are binding is tilde. Yeah. Okay, there we go. Alright, don't save. So these can both be default arguments 0 and 1. Okay. Map list number function onto A. Okay. And there is our list of strings. Define hash string dot. Let's see. So we're trying to return a number. String dot integer. Okay. Now there's probably a way to code this as well. The alternative is to read through the string and ask for the first instance of 6. Well, read through the string until you encounter a 6. Well, actually, it's not even clear that this is going to give a faster time. But I'm assuming we're going to get 0 because there is such a limited number of cases for time. I mean, we will be getting 0 probably. So we won't be able to test whether this is correct. If this had had a more convenient ordering, we might have fallen into more of a rhythm of typing, I guess, but whatever. Alright. Alright, now hash ref hash string dot integer num. Yeah. Okay. So actually what we could have done is this outputs numbers in the same order, I assume? Yeah. Oh no. And then map. I assume that produces the same ordering. Yeah. So I'll put that in the code as well. As a gesture towards how the hash table was written. Hold on. Would it have been better to do? Yeah, but we don't have remove duplicates. Yeah. We could have like a set where we keep track of duplicates. But the point, we don't have duplicates, so we need to do this with lists, because otherwise we have to hold on to all of the combinations. So what happens if I do combinations? I don't guess that automatically does, no. Okay. Oh, Alright, well that was going to be real cute when I removed this line and then we had 69 lines of code, but yeah, we forgot that you could have intermediate cases. Okay, and then that's going to, well, how much is that going to balloon? Alright, so this would be define define B. I mean, we could just make combinations and then remove everything with more than 5, but so this is going to be, yeah, we should just copy and paste this. So 4, 3, and I guess we could do 2 by hand. Actually, I could probably do, yeah, whatever, CD. So we could name this 5 combinations list 4, 3, 2. Okay. And just as a joke, I'll do 1. Okay. Okay, define 5 strings list, no, 5 numbers, 5 strings list. This is now 5 combinations, 5 numbers, and that is the template. 5, 4, 3, 2, 1. 4, 4, 4, 4, 3, 3, 3, 2, 2, 2, 2, 1, 1, 1, 1. Okay. And now, define strings list append, which is a bit horrible. Yeah, I mean, the alternative is that we just print them out in a row and do a little bit of formatting. I mean, actually, the alternative here would be that we pass the same lists through, right? Right, well, so, hold on, what time is it? And why doesn't Windows want to show me? Alright, so, let's see. Yeah, well, so we've, if we really wanted to streamline this, we would have 2 lists. The numbers list and the strings list. We don't really have better than, yeah, but we can pass these one at a time, would be the point. We can pass these in one at a time. And then instead of running mapping like this, we would pass in the list. Alright, then we don't need default arguments. We could still have them. Hold on, now I have to think about infrastructure. Let me see. Because this works on a number at a time. Define list to list. Combinations to integer list function. Input list output list output strings list output number list. Seems like it would be much easier if we did for each and had a variable. Define strings list null. Define number list. Numbers list null. Okay. Now we make define full. Let's see, complete list. List of. Let's see, 5, 4, 3, 2, 1. Okay. I assume this does not cost more as a consequence of these costing more. Actually, we could test that. List generator time list AAA. Yep, 0. which would otherwise cost something substantial. So arranging these things into a list costs 5. Whatever 5 constant means here, as opposed to 5 million or whatever. Alright, so we have our list, and what we want to do is map for each lambda x set strings list const. Let's see. Const this thing onto accumulator integer. No, we can do that. Yeah, we don't need to commit to this list operation because we can just do that in the for each. Set strings list const. Okay, let integer value, just say value integer list to number function x, keep the default arguments, sure. Const this a onto value integer, rather const the output of this on value integer onto strings list and set numbers list const value integer onto numbers list. These capitalize on the integers are killing me. Okay, so now we for each that onto let's see, this would be lambda integer list. Okay, this is map lambda right, now the problem with this operation is that I still have to perform the edit. Right. Map. So actually we'll design that. I'm not going to do that by hand, that would be ridiculous. Lambda in combinations list wait, why wouldn't it be map? Let me think here. Right, it would be this onto in combinations list, and it would be this onto complete list. copy that over in case I change my mind. Alright. And what do we want to call, what is that going to return? So show me strings list and numbers list. Okay. Actually, it wasn't that many more. Yeah, actually, this would be kind of a trivial task to do by hand at this point, but then I'd have to admit that I did it by hand, which I'm unwilling to do. Alright, so now we need to code up an actual, Now we need to code up something that can read the string list and perform the necessary adjustment. Okay. Define the string tuner function. Input string. Output. No. Let's see. No, yeah, there are cases where yeah, I mean, you want to discard the cases where, but again, yeah, this is a case where this is a point where, yeah, the what constitutes an edge case for any given procedure is going to differ. But yeah, if we could throw out all of the if we could throw out all of the numbers that are only nines, we would have a much more efficient procedure because we wouldn't have to ask about position. Because we would inevitably encounter a 6. Yeah, I'm gonna do that. What do I mean do that? I'm gonna take all of these. Define that 9less list string. Okay. This should be a list. Alright, so we're gonna delete all of the mono 9s. Oops, what are we deleting? Oh no. Hold on, let's make sure we didn't delete anything else. Okay, that one's fine. That's fine. Alright, so now there are no 9s, and so we don't need a guard because every string is effectively doped with the first 6 that we encounter. Okay, so let's see. If string ref if equals chart equals string ref input string input position 6, then string to number begin string set input string input position 9 string to number input string else string tuner function input string add 1 input position. Okay, so now let's run define tuned strings, tuned lists, no, tuned numbers, list integer, map, string tuner function onto 9 lists, lack 11 9 lists. What? Never mind. Yeah, okay. That in itself was kind of horrible. Yeah, so we need, hold on, string 6. Yeah. That is horrible. Why is everything to do with strings just so horrible? So horrible to work with. Yeah, I mean, I need to be able to edit this text using code, which is probably why we're learning Emacs, but yeah, well, I mean, the alternative is that we find, yeah, okay, sequence. Well, they might just be horrible in general, I don't know. But okay, so we start here, we find every copy of 6, and we replace it with char, and we put a space before it, but that doesn't work because if it's the first in the string. But actually, so it wouldn't matter. It wouldn't matter if the space is before and after because space is a char. But yeah, this is horrible. We can't replace all either. If we have to do the same thing with nines. And actually, we have to replace. We have to get rid of all of the quotation marks as well. Takes less time, admittedly. Model could have done this in less than a second. Okay, now. Yeah, I mean, we'd want to do all of the preceding parens with string. Or not parens, but quotation marks. This is so tedious. Could we admit? Could we claim that we didn't just do what we just did? I mean, yeah, nobody knows. Nobody can see what we've done. All right, so tilde a. Is there an option to do that with mutable string instead? Yeah, oh yeah, terribly useful for numbers. Alright, let's see if this... Okay, let's see. String set A05. Okay, so as it turns out, we can replace this with R. Okay, so let's comment that out for the moment so we don't get 1,000 errors. Show me strings list. Yeah. Let's see. So that we don't get 1,000 errors. All right. Yeah, this even is a little bit cheating because, I mean, the point of doing this is to demonstrate that we have an effective method for constructing a hash table. And it's the same observation we've made a few times about big O, that you think you have an efficient procedure, but if you're off by an order of magnitude, you're off by a billion, 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 or whatever. Like you had as well not have produced a procedure if you're off by an order of magnitude. Similarly here, it's easy to search by hand and remove all of the 9 elements, all 9 elements. I say it's easy, but I feel like we missed one. Did I? Apparently not. Alright. So, how would we remove this? Yeah, there's not really an efficient way to do that. Well, I mean, if we wanted an efficient way of doing that, we would have to go further up the stream. We can't do that with... I mean, yeah, we could filter. Actually, I'm not sure exactly how we would filter that. I guess I'll note that I cheated here a little bit. Yeah, but I mean, what good is it to avoid the mapping if you otherwise have to do it by hand? Because again, this could go up into the manyth digits, and you could have to delete more selectively, or more elements rather. We found out a way around this. What do I mean? So... let me think here. So I could preclude... Though then actually we have to... We would have to have a separate list for all of the removed elements, and we would need an if. So the general form would be we get the value and we say if predicate begin, otherwise begin. Define predicate removed. Yeah, there's not a good predicate for this is a problem. There's an expensive predicate. That expensive predicate being or equals value integer 999 999 9999 9999. Yeah. It's also not clear that we'd prefer to interrupt this mapping and for eaching to remove those elements rather than getting the output list and cycling through that. Mm-hmm. Alright, now the 9-less strings is simply strings list. Okay. Map string tuner onto strings list. Okay. Predicate, or their hash table, hash append predicate list, predicate numbers list onto append predicate numbers list onto numbers list. strings. No. Tuned numbers. Right, append predicate numbers. Onto tuned numbers list integer. Okay. But in practice, what that means is copying and pasting because I don't need to run the append. Actually, we need, let's see, remove, we have tuned numbers somewhere hiding in here is a display of the strings list. Not sure where that is, but I don't need it. So it's going to be numbers list. And tuned numbers list. And then at the top, predicate numbers. List, yeah, I'll go in the other direction. Here. Alright, so we have these two lists in a row, and then we have these. Alright, so it's gonna be this. Rather, random hash. There's not a convenient way to do this. There's not a convenient way to lay out. What time is it? Alright, I should stand up. There's not a convenient way to put two columns of numbers side by side. Now, if this was a hash, if this was a mutable hash, I don't know. Alright, I'll be right back. I had a mutable hash, mutable hashes are done using const pairs. And what is the significance here? Let's see what my shoulder can do today. Do some low pressure Tai Chi. Right, if we had a mutable hash table, mutable hash tables work with const pairs. So I could streamline the process, produce a list of const pairs, and call that the hash table. Okay, but then we're stuck with a mutable hash that we never need to update. I don't want a mutable hash if I never have to update it. I want an immutable hash. But nothing is striking me. If I could simply copy and paste, I would. Yeah, let me put on my... Now I am ready for exercise. gymnastics chair would return any hits. You know, when I was a kid, I was interested in gymnastics. Not interested in the sense of participating, because that would have been frilly and girly. So to say, had I my druthers, I would have exercised a lot and done gymnastics, but I didn't have my druthers. As opposed to my brother, who liked baseball and got a lot of support for that endeavor. But now, if I wanted a gymnastics chair, I'm just getting a job away. Which is, I don't know, a decade away. Alright, Internet, what say you? Gymnastics chair. Uh-huh. That's a little bit suggestive. Well, yeah, so you say, though that's kind of ruinous to feel. Yeah, indeed. Like a bench. Yeah, none of this is really what I was thinking about, though. I was thinking, like, chair with rings on it. Okay, well, whatever. Looks like the answer is no. Alright, let's see. Well, alright, how are we gonna... right, so we can't, we can't put one of these after the other. Okay, so actually what we would have to do then is... we'd have to const them in order. Yeah, I don't want to do, I don't want to do that though. Let's see. So we'd have to have it so that this list of numbers was 6 and then 9, then 6999, 6696, 9699, etc. Which maybe we could do, though it's not clear exactly how we would do that. No, actually, it is kind of clear how we would do that, isn't it? What do I mean? So, instead of having this intermediate strings list, we would do... Okay, so we move string tuner up the stack. We don't have a strings list. We didn't need to do this anyway. We didn't need to do const the string on anyway. That was a mistake. But okay, so we delete this. No, we still do this, but we don't need to begin. No, we do need to begin because this is an F. Yes, okay. And now here, the order that we want is this const on first. So const string tuner function running on this. Okay, onto strings list. Okay. So this would actually still be numbers list. Okay, and then we don't perform this mapping, we don't have tuned numbers. So this is actually going to be const value integer onto const value integer onto predicate numbers list. Okay, and then so define, well, we don't really need this defined. We need the output. Oh, never mind. Now we need to see numbers list. Just need append predicate numbers list onto numbers list. Okay. There you go. We did it. Okay. Hash this thing. My heart is kind of acting up at the moment. That's concerning. Alright, so this is going to be hash ref. Rather define hash uh, 6.9. Okay, sure. And now this will be hash ref. Hash 6.9 num. Wait, this should be here. And now we have everything commented out. Alright. Now the critical point here, though, is that this is replicable. Yeah, this isn't so replicable, but this scales well with more elements. Each digit, I just have to add another 6, 9 and add another define 6. I mean, actually, yeah, we could have handled this. Yeah. We could have automated this process. Because all you'd have to do is you'd start out with this 6, 9, and then conson 6, conson 9. Rather, conson 9, conson 6, but it doesn't matter actually. And then oh, alright. Time. Yeah, we kind of have to make a decision. We either are going to say we're hell-bent on completing a large number of these puzzles, or we're willing to dilly-dally and you were given a string S consisting only of letters A and B. In a single step, you can remove one palindromic sequence from S. Return the minimum number of steps to make the given string empty. A string is a subsequence of a given string if it is generated by deleting some characters of a given string without changing its order. Note that a subsequence does not necessarily need to be contiguous. That's more complicated. And this is easy. I mean, is there a way to do this without creating the new strings? Well, I mean, you could edit the string in place, put in a dead char. And then pass over the dead char. Oh, anybody in chat? Nope. Alright. So we cycle through with left pointer, right pointer, typical technique. Okay, and in this case, every time we find equality, we yeah, though I feel like we would need to do some proving. What do I mean? So I set up the left pointer and the right pointer. Let's do this. I'm not sure this example will work for what point I want to make here. Oh, actually, we need to. This was 1323. Actually, this is 1329 complete. What was the thing I just saved? 1323, rather. Yeah, that's not it. Yes, replace it. Alright, so we have BAABB. Okay. And now we have a pointer left and pointer right. Okay. And now they're the same, so we move them in. Now they're not the same. Okay, and so we move one or the other, it doesn't matter which. Let's suppose it's in this direction. And oops. Okay. And now we don't get any further matches. Alright, so now round 2, we'll just not have the phi's because we ignore them. Oh, so we never found equality. I guess that means that we delete the right one. That's a convenient conclusion to reach, but also there's no equality whatsoever, so we would have to spend a tempo, deleting this. Okay, then we have AA. Alright, so now the question is this process where we stay still. Well, and then we could have something like this. Alright, now the question is, does this actually work? Seems like it does. Yeah. Maybe not if the sequences couldn't be contiguous, but I would only investigate that as needed. Alright, well, then this seems to work. Seems, whatever that means. Okay. String cycle function with S string left pointer position. Well, yeah, that's all there is to a pointer. So this is actually the number of rounds that are required. Define a round count integer is 0. And then actually define edit boolean false. No, you don't want to do that because the idea would be edit boolean to answer whether we've performed an edit or not, but you'd be setting that boolean every time you performed an edit. Well, yeah, but then you don't need a boolean at all. If you had two distinct procedures where after the first edit you go to the second procedure with all of the same state, you wouldn't need the boolean because you'd know you performed the edit because you were in the second procedure. Yeah. Okay. Now, so what is the horrible? Why are you gonna do this with length 1? Why? Tedious. I guess we'll just do an if statement before we start. Yeah, there's a point that we have to cycle through all of the dead elements. Well, what? You could do string to list instead. String to list and reverse string to list. String to list and reverse string to list, and then use lists instead. And the idea is that no, that's not going to work. Yeah, because you'd only be shearing one. If I'm only moving the left pointer, I'm only shearing the forward list, and then I wouldn't have a way of keeping track of where I am in the two lists relative to each other. Yeah. String cycle function, left pointer position, right pointer position. Okay, active left char string ref string left pointer position. Active right char string left string right pointer position. I guess we need left cycle. Cond char equals. And we also need some way of specifying. Let's see. If greater, yeah. Is there a better way of doing that? No, not really. I don't think so. If greater than or equal to. Left pointer position, right pointer position, if equals. Left pointer position, right pointer position. Else lat cond char equals char equals active left char, active right char. Then string set s string left pointer position. Oh, Actually, you know, we could put, there might be an edge case here that I'm not thinking about. Probably we could put the let definition before the first if. What time is it? Because it doesn't matter if we've overscanned. I mean, we'd pay 2 extra string refs, but with the benefit of being able to wrap everything in a nice condition instead of this nested if like this. Well, it would be cond greater than the if. No, it's not efficient. I think, given how OR unwraps, it would be the same as if you did 2 consecutive, and then you don't have to ask the if you do OR, you have to ask the follow-up, so instead we're going to ask char equals active left char phi If only we could delete numbers. I mean, you. Oh, that's interesting. You could have a heap. Huh. You could have a heap and take heap min and then heap remove min. But you have a permanent copy of the heap, and the idea is that anytime you remove an element from the string, you remove that number from the heap, and then you extract the next position for your string ref from the heap. And then you don't have to perform these string set operations, and you don't have to perform these predicate checks. Interesting. So you'd have to have two heaps. You'd have to have left heap and right heap. Okay, let's see. Define. Why would it be a heap? So we can do heap min. And I guess we need them sorted, but well, the alternative. Oh, that's interesting. The alternative is that we have a forward and backward range list. That would only work if you cycled all the way through to the end. And you can't make the range stop in the middle of the string because the left and the right pointer aren't always going to meet at the middle of the string. So you'd be cycling through a range list, consing the elements into a new list as you cycle through them, and then not consing them if you encountered equality. And then the idea is that you pass the you'd flip the lists, which is elegant and wrong. You'd flip the lists to turn them into the other list. So let's see. The note here, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then you'd have 10. Let's do this. 9, 8, 7, 6, 5, 4, 3, 2, and 1. Alright, and then between you have, let's make it a nice odd number. How does this work? Let's see here. All right, so we're gonna have, let's see, that should be correct, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So A, B, C, D, E, F. We need non-equality, right? B, B, C, D, E, D, C, B, A. Sure. Okay, and now what is the idea? The idea is that so we get equality. Okay, so we're going to delete here, delete. Well, no, I mean, well, yeah, okay. We'll delete here. And then we delete here. Incorrect. We delete here. Wait a minute. We'd have to have the reversed string, right? Yeah. Okay, so we'd have, for this example, AA, BCDE, DCBBA. Alright. Okay, so now I delete 10. Okay. This is quite difficult to think about. Let's see. So that was. Actually, I think. Yeah, we might want 2 strings, but we only need pointers on 1 since this is our preferred pointer format. Alright, so now, what is the idea? Quite inconveniently, yes, well, we already observed that this doesn't work, so it shouldn't be surprising that it's not working. Yeah, and it's not clear what this is trying to represent either, which is maybe the bigger problem. But what this is trying to represent is that, so we're stuck on A, we'll be stuck on A all the way to the end, so I guess I'll just copy that over. Let's see. Dot, and then. Alright, and then we would end up deleting A. And what that means is that we would have. Let's do this. Incorrect. Alright, now we would delete 9. Okay, but there's a critical aspect to this idea that is not represented here, which is that we would be putting these elements into another list. Fancifully, as we cycle through the numbers, we would be putting them into another list. The problem here is that the other list now would only include, well, it wouldn't include 10 because we deleted that. Okay, if we made a mismatch at the beginning, I don't know, it's, this example is spiraling out, and I already know in advance that it doesn't work, so my motivation to fix this example is not so high. But the idea is that we're cycling through the numbers, we're constantly them onto a list, but that means they're in reverse order. Okay, and then, so 10 would go in the list first, then 9, then 8. And then similarly over here, 0, 1, 2, 3. And then we would flip the lists. Doesn't work though. Not unless I'm willing to perform an append every step, which is gratuitous. Because I could take the partial list and append the... Well, no, that wouldn't work either, because we wouldn't have sheared off elements from the end of the list. So, like, this would still have 0 on the end, even though we've deleted 0, and appending isn't going to change that. Yeah, there's problems with that idea. Okay, what time is it, by the way? Let's see. Alright, it's time for exercise. But okay, the heap idea, where we heap min And we keep a global copy and we run heap remove whenever we. Well, for the local copy, we run heap remove min every time so that we can get heap min. Let's see. So heap remove min and heap min. Alright, what are skip lists? You always have to wonder, is there just some better primitive out there? Just some better primitive. What if I just knew all the primitives? The next primitive is the one I need to learn, and then I'll have an efficient program. Alright, time for exercise, and then time for lunch. So, put on your dancing shoes, let's get busy with exercise. Now, it's not clear that I had a muscle tear. It might have been something other than a muscle tear. In which case... Well, I don't know in which case what, but... Well, if I did have a muscle tear, I assume premature reactivation of the muscle would be deleterious. More deleterious than if I had, for instance, a cramp of some kind. But the idea there is that we can up the pressure a little bit. See what happens here. I immediately regret. Alright, let's keep the pressure low. There's a point there. It looks more elegant to sort of throw the body back because you can do it in one smooth motion. But that also lacks control. It's a little less elegant looking. Do this kind of stop and start. If you're incapable of stopping yourself mid-motion though, you have less control, I suppose. Yeah, like they're throwing my leg. these nights, warm night, going out to a track. Guess I'll need to get some shoes, running shoes. Well, shoes that I will use for running. Well, yeah, but I mean, how much am I actually? Well, I need a new pair of shoes anyway. Current pair of shoes has a hole in the sole because I've had the same pair of shoes for about 10 years. And actually, the rest of the shoe is doing fine. I think I might get it resold. But then they're not running shoes. Well, I don't know. They have the same soles that I would get on running shoes, so why aren't they running shoes? It's because they're made of leather. Oh. Nevertheless. Alright, lunchtime. Now we're gonna see what my mile is. I'm interested to know. Anyway, I'll be back in about an hour or so for, well, probably we're watching more chess. Alright, see you soon.